This presentation will share with you the safety regulations associated with the Northern Kentucky University Department of Chemistry and Biochemistry. The Department of Chemistry and Biochemistry at Northern Kentucky University takes safety extremely seriously. This presentation will cover department-wide safety rules and guidelines. Faculty research mentors may also establish additional safety regulations. Students who fail to comply with the safety rules outlined in this presentation or those of their research mentor may be dismissed from the lab. Throughout this presentation, items that you should always do will be colored green and preceded by a check mark. Those things you should not do will be in red font with an X in front of the text. And those items which are recommended or best practices will have a pointing finger in front and be colored blue. There are several people in the department who can help you with your safety questions and concerns. Your primary contact should be your faculty research mentor should you have any issues in the lab or have any questions about the safety policies. Our stockroom contacts are Chris and Jim. One of them should always be available in the stockroom should you need their assistance. Christine is in the front office. She can help you with campus contacts and locating individuals if you cannot find them. Of course, I, Dr. Russell, am also around should you need any assistance. The contact information for all individuals associated with a particular lab can be found on the lab door. First, we will discuss some personal safety requirements and recommendations for the lab. Here are some personal safety requirements. First and foremost, be aware of your surroundings. Many accidents can be avoided simply by surveying the area you will be working in before you start. Wear your safety glasses in the lab at all times. Wear closed-toed shoes in the lab. Your faculty mentor may have other clothing requirements, but they are not department-wide. Note the location of the safety equipment in the lab. Experiments are to be performed in fume hoods unless otherwise instructed. This is particularly important for synthetic experiments. And all accidents, no matter how small, must be immediately reported to your faculty mentor. Below are some things you cannot do and some best practices. There is absolutely no eating or drinking in the lab. You should never taste chemicals or directly inhale vapors. As a best practice, should you wear gloves in the lab, try and take them off before you leave. Avoid wearing gloves in the hall whenever possible. Remember, anything you have on your gloves could get transferred to things you touch in the hall. Remember that you are never to eat or drink in the lab. However, if you do need to bring in your lunch, you should store it in a closed container in the drawers in the desk area. If you have a drink container and it is not watertight, it must stay in the hall. It cannot come in the lab. It is recommended that you wear gloves when using chemicals, but remember to avoid wearing gloves outside the labs whenever possible. Wash your hands thoroughly before you leave the lab. You should do this whether or not you wear gloves. Some other recommendations include wear long pants. Spills on your pants are much better than spills on your skin. Wear glasses instead of contact lenses. If chemicals do get in your eyes, it is much easier to wash the chemicals out if contact lenses don't have to be removed first. Don't place your cell phone in your hood or on your bench. Remember, spills can take place on your cell phone, and then anytime you pick that up, that's going to go right against your face. Also, keep your workspace clean. Lab access. As a general rule, only authorized researchers should be in the lab. However, on occasion, there are visitors, such as family members or someone from out of town. Any visitor must be approved by your research mentor and must be accompanied by an authorized person. Visitors will be required to wear eye protection and any other personal protective equipment required by the faculty mentor. Things you shouldn't do in the lab: do not prop open the doors, do not unlock the doors, and there should be no study groups in the lab. The labs really are meant to be for student undergraduate research. Research during normal business hours. The normal research hours are Monday through Friday, 8 a.m. to 5 p.m. While it is best practice never to work alone, students are allowed to work alone for brief periods during normal business hours. During that time, there is generally enough foot traffic in the building that people frequently pass by the lab, and they would be able to spot if something went wrong. Likewise, a researcher would have a much easier time finding someone if they needed help. Also, a best practice is to notify your research mentor anytime you're working in the lab. When working outside the normal business hours, you must have at least 2 researchers in the lab. Now, this can be in separate labs with an adjoining door, but not 2 researchers on separate floors or across the hall. And remember, the preference is always 2 researchers. However, for really quick things, such as coming in and just turning off the stirring on a reaction or running an NMR spectrum, that second person could be a friend or a family member. But remember, that person must wear safety glasses and other appropriate PPE to be in the lab. When working outside the normal research hours, research can only be performed when the building is open. That is Monday through Friday, 6:30 a.m. to 11 p.m., and Saturday and Sunday, 7 a.m. to 5 p.m. If you were found in the lab outside of those times, the Department of Public Safety will ask you to leave, and you may lose your research privileges. Next, we will discuss the handling of chemicals and hazardous waste management. Best laboratory practices include using only clean glassware. Anything that starts in your glassware may wind up in your reaction or in your analysis. Whenever you're taking chemicals from reagent bottles, always use clean pipettes, spatulas, or syringes. Chemicals are very expensive and no one wants to use contaminated reagents. Make sure you read the labels at least twice before you use them to make sure you're using the right chemical. And then only use the quantities and concentrations required for the experiment. Again, chemicals are very expensive and we don't want any waste. Some things you really should try to avoid. You should never pour water into concentrated acid. Always add acid slowly into water while constantly stirring the mixture. When heating liquids in narrow containers, such as a test tube, make sure that the open end points away from yourself and others so that any boiling or popping solvents does not hit anyone. In general, you want to avoid heating liquids in narrow containers anyway, like graduated cylinders, volumetric glassware, and stuff like that. Use a round bottom flask or a beaker. Lastly, do not weigh chemicals directly on chemical balances. Use a weighing paper, a weighing boat, a watch glass, test tube, beaker, anything that will protect the balance pan. Balance pans are very expensive, as are the balances, and you want to keep them free of corrosion. Clean up any spills, even if they're not on the pan immediately. Handling of chemicals. When transporting chemicals between labs or rooms, they should always be in a secondary container, a bin or bottle holder. If you are moving many chemicals at one time, you should use a cart. If you are transporting chemicals between floors, you should always use the freight elevator. Never use the public elevator to transport chemicals. If you have empty chemical bottles in the lab, you should check to see if they have an inventory label. If there is a label, you should remove it and place it in the designated location in the lab. Your faculty mentor will be able to tell you where that is. Once there is a full sheet of inventory labels, bring the sheet to the stockroom so the chemicals can be removed from the inventory. Several of you may need to use gas cylinders for your research. Gas cylinders are a potential safety risk, so you will need to pay close attention as to how to use them. Students should only need to open and close the main cylinder valve. Because the same cylinder may be used for multiple hoods, it is important to know when it is in use. Students should put a magnet with their name on the tank whenever the tank is in use, and remove their name tag when they are done. If a student is done using a gas tank, they should not turn it off if any other name magnets are still on the tank. When a gas tank is empty, students are not to change the tank. The tank will be changed by the instrument manager or the stockroom staff. When the main cylinder pressure is below 500 psi, the cylinder is considered empty and you should notify Jim. Here are some images of a cylinder as you might see it in the lab. The left image shows the top of the tank with the main cylinder valve. That is all you should have to touch. Notice that there are name tags on the tank indicating that the tank is in use. Don't forget to put a name tag on the tank when you are using it so it doesn't get accidentally turned off. Attached to the main cylinder valve and above, you can see the regulator, which is shown in a close-up on the right. Do not adjust the valves on the regulator. They are set by the faculty and staff. There are two pressure gauges on the regulator. The one on the right, which is closest in line to the tank, is the pressure that is left in the tank. If this value drops below 500 psi, the tank is considered empty and you should notify Jim. The valve on the left is a much lower pressure needle valve, and it is used to regulate the pressure that goes to the hood lines or to wherever the gas is needed. Hazardous waste is always a concern in the chemistry lab. Generally speaking, there are 4 types of waste containers you will encounter in the research lab. They are liquid waste containers, solid waste containers, containers for broken glass, and containers for sharps. We will discuss how to dispose of items in each of these containers individually. First, some general rules about hazardous waste management. All waste generated in the lab is considered hazardous. All waste must be placed in appropriate containers, and in the case of chemical waste, those containers must be in a secondary container in case of spills or leakage. Waste containers holding chemicals must be kept closed at all times except when waste is being added. It is very important that you follow the guidelines for filling out waste labels for the chemical waste. First, make sure the waste container has a chemical waste label the minute the first hazardous waste is added to the container. You can get a hazardous waste label from the stockroom. The full name of the chemicals must be written in words. No formulas or trade names are allowed. It is also important not to put dates on the label. The date is only placed on the label by the stockroom staff. There are regulations about when waste must be disposed of, and those are based on the date on the waste container. If you are recycling solvents, those solvents should not go into a hazardous waste container. Technically, it is not waste because it will be used again. There are different colored labels that you can get from the stockroom that are for recycled solvents. Now let's discuss the waste management of liquid waste. There are 3 types of liquid waste that we deal with. Aqueous waste. These are solutions of inorganic acids and bases, and when they are highly diluted, they can go down the drain. However, if there's aqueous solutions that contain any toxic or heavy metals or organic compounds at all, usually this comes from an extraction, they must be placed in a waste container for disposal. Organic waste includes most non-halogenated reagents and solvents. These should never go down the drain. If you have a reactive organic that must be disposed of, it must be carefully and completely quenched before adding it to any existing organic waste. This will avoid any hazards resulting from reactions taking place in the waste bottle. Halogenated organic waste. This includes all halogenated organics from solvents to reagents. Extra caution should be used to see that these toxic compounds do not go down the drain. They are to be collected separately from the normal organic waste because they must be destroyed by other means. Liquid waste is most commonly disposed of in used 4-liter solvent bottles. Do not use the 20-liter drums as waste containers. These containers cannot handle corrosives and are prone to leak. You should not fill any waste container to capacity. Leave some room at the top, about 2 inches, so that the solvents can expand without too much pressure buildup. As a rule of thumb, you can use the shoulder of the bottle as an indicator when to get a new bottle. It's always better to have a bottle that is a little underfilled than one that is overfilled. Finally, you should not transport waste. When a waste container is full, place a sticker on the cap and notify the stockroom, letting them know when and where the waste can be picked up. Solid waste. Solid waste is often disposed of in used plastic reagent bottles and also require the same waste label the minute any solid waste goes into the bottle. There are 3 types of solid waste we most commonly deal with. Some items, such as magnesium sulfate, sodium chloride, or sodium bicarbonate, can be dissolved and go down the drain as dilute solutions. Larger amounts can be placed in the normal garbage. Now, that is true as long as these compounds are free from other potentially hazardous chemicals. If they are not, then they need to be disposed of as solid waste. Silica gel needs to be treated separately. It is considered hazardous because of its very small particle size. It can be inhaled into the lungs. Used MPLC columns can be put in the normal trash because they are sealed. Heavy metals such as mercury, lead, chromium, they must always be disposed of separately. They are never ever to be placed in the garbage or go down the drain. Broken glass goes into the glass disposal box. If you can, rinse the glass to minimize any chemicals that go into the box. When the broken glass box is full, call the stockroom. They will close and remove the box. Do not try and close the box yourself. Never put chemicals or any other trash in the broken glass box. The box is exclusively for broken glass. Also, never put broken glass in the regular trash. This creates a serious hazard for our custodial staff. Sharp things are used routinely in the research lab, most commonly needles, but also razor blades and other things that you could accidentally poke or cut yourself with. If there are chemicals on those things, that could take a bad situation and make it even worse. If you are utilizing sharps and getting ready to dispose of them, you should place them in a sharps container. These red containers are designed so sharp things can go in, but they cannot be taken out. If there is no sharps container in the lab, you can get one from the stockroom. Plastic syringes can be placed in the regular trash once they have been thoroughly cleaned and made inoperable by removing the plunger and cutting the barrel in 2 so that the syringe could not be reused. Do not recap needles. This is the easiest way to poke yourself. Consider placing a needle you wish to reuse in a cork ring or rubber stopper like a pincushion. We will now take a few minutes to discuss the safety equipment found in the laboratory. When you enter a lab for the first time, you should familiarize yourself with the location of all the available safety equipment. When returning to a lab, you should take a moment to refresh your memory as to where to find the safety equipment. These include the fume hoods, fire extinguisher, eye washes and safety shower, safety blanket, fire alarm, and emergency gas shutoff. A few comments about using fume hoods. You should conduct all experiments in the fume hoods whenever possible, especially when they are synthetic reactions. You should keep the sashes down at all times except when you are working directly in the hood. Even then, you should try and keep the sash as low as practically possible. This helps maintain optimum airflow. Try to keep clutter to a minimum. Do not store reactions or chemicals in the hood unless absolutely necessary, and then for as short a period as possible. When working with potentially explosive materials or reactions under pressure, the sash is not enough to protect yourself or others if something goes wrong. You must also use a blast shield in addition to having the sash down. As a best practice, whenever performing a potentially hazardous reaction, or any reaction for that matter, It is a good idea to leave a note on the outside of the hood indicating what you're doing. The more information you can provide in your note, the better, such as the chemical reaction, the reaction temperature, time, and even a lab notebook page number. If you are doing something hazardous, you should certainly notify the other people in the lab of your experiment, and your faculty members should also be aware. If the fume hood alarms are going off, do not mute them. They are going off for a reason. Notify your faculty mentor or the stockroom so they can contact facilities management to address the issue. There are eye washes and safety showers in the labs and the hallways throughout the building. If you need to use them, by all means do so. But make sure your faculty member is notified immediately as well as public safety. They are aware when a safety shower is pulled and will come to investigate if they're not notified. There are first aid kits in the research lab as well as the stockroom. If you have small cuts or wounds, you can use the first aid kit to treat yourself. But remember that all accidents must be reported, so you need to notify your faculty mentor regardless of how small the injury may be. If it is a larger injury, contact your faculty member immediately, followed by the stockroom and/or the front office for assistance. Fires are always a potential hazard in a chemistry lab, and there are a few things to keep in mind. We do have fire extinguishers and safety blankets in our labs. Fire extinguishers are only for small fires and are only to be used if you are properly trained. If you have not been trained, you should not use the fire extinguisher. If you want training, please let your faculty mentor know and we'll see that you get enrolled. If you or someone else in the lab catches fire or your clothes are on fire, use the fire blanket. The fire blanket will help smother the flames and put out the fire. But do not use the fire blanket on a chemical fire or any other type of fire in the lab. It is not intended for that purpose and probably won't put the fire out. In fact, it could make the situation worse. Never try to put out a large fire. If there's a fire and you have any reservations whatsoever, if you are not trained in the use of the fire extinguisher, or you think the fire might be too big, or you're uncomfortable trying to put it out, don't think twice. Pull the fire alarm and leave. In the event of a fire alarm, if it is safe to do so, turn off any gas immediately and leave the building as soon as possible by the nearest exit using the stairs. Do not use the elevators. If you are the last one out of the lab, make sure the door is closed behind you. That can help isolate a fire so it doesn't spread. Once outside the building, make sure you keep yourself at a safe distance, across the street or in another building. There are a lot of windows in the building that could blow out, creating a serious risk of injury if you are too close. When it is time to re-enter the building, the only individuals that can give you the all clear are those from the Department of Public Safety or the fire department. Faculty and staff must also wait for the all clear from those individuals before re-entering the building. Although it doesn't happen very often, on occasion, Northern Kentucky does receive tornado warnings from time to time. If NKU is in a tornado warning zone, the fire alarm will sound along with an audio message. If there's a tornado warning, you should go to the underground portion of the first floor. That would be the long hallway behind Darwin's Cafe, farthest from the student parking lot down by the physics labs. You should remain there until the all clear is sounded. Whatever you do, do not go outside or remain near any exterior doors or windows. A few notes about instrument sign-up. There are many instruments that you may use during your research time. Some are very specialized and only used by one or two groups. In that case, your faculty mentor will be able to provide coordination. However, there are a number of popular instruments that are reserved through the web. You can book through the department website, chemistry.nku.edu, and select the instrument schedules link. If you are a frequent user, you might want to bookmark this link. These signups are for the 500 MHz NMR, the MPLC, the UV-Vis spectrometer, and the glove box. While these pages have more detailed instructions, I just want to mention a couple of rules about the most popular instruments. The NMR. During open NMR time, students can reserve 20-minute blocks. In fact, they can reserve 2 back-to-back blocks, but no group may book more than 1 continuous hour except for off-peak hours. The MPLC. Students can reserve up to 90 minutes, but you're encouraged to only reserve what you need. If you really think that you can complete a separation in an hour, then only reserve an hour. Use your experience and the experience of your lab mates to help guide you. It's very important to cancel reservations that are not going to be used. Do not monopolize the instrument if you're not going to use it. We all need to share. Of course, communication is key. If you're not going to use the instrument and you see someone has signed up after you, contact them and let them know that you don't need the instrument, so maybe they can use it earlier. If you need a few extra minutes and you see someone has signed up after you, reach out to them. Perhaps they will be able to let you use a few more minutes so you can get done what you need to do. Lastly, we need to discuss a few research considerations during these COVID times. For NKU's COVID-19 information, you can go to the website www.nku.edu/covid19.html. With respect to research, we expect you to comply with all of the NKU guidelines as outlined on their website. We expect you to participate in the Healthy at NKU anytime you come to campus. In the lab, you must always wear facial coverings at all time, even when you're alone. When there are others in the lab, you have to do your best to stay at least 6 feet apart. Lastly, be scrupulous in cleaning your space and common spaces that you use. When you leave the lab, you should leave it at least as clean, if not cleaner, than when you came in. This concludes our Department of Chemistry and Biochemistry safety training. If you have any questions, do not hesitate to reach out. Our faculty and staff are here to help. On behalf of the entire faculty and staff, I want to wish you a productive and rewarding research experience.